Hello and welcome back. My name is Corey, you're my rubber ducks, and we are in the middle of creating a programming language from scratch. The programming language is named Tang. It's a template language, hence the name. And we are using modern-ish C++, tools such as Flex, Bison, ICU when we get there. And of course, as always, working in a terminal window, Vim is our editor. And I am just going to kind of jump into today's target or today's episode because I know I'm going to have to pause it in the middle and meet up with family and well, that happens sometimes. So at some point there'll be a slight break. But what are we doing today? Well, we want to implement a continue and break. What we did last time, we had multiple episodes working on getting functions to work, and they work pretty well now. Well, we want to implement, like I said, the continue keyword and the break keyword. And of course, it's our language. We can decide how we want to implement it. And we're just going to jump in. I always say nothing up my sleeves. I don't have anything pre-prepared. This is 100% live programming, which means you see all of my mistakes, all of my, what was I thinking about moments, and all of my syntax errors. But you get to see me debugging and reading the error messages and figuring out what's going wrong. So, I'm not an expert C++ programmer, but I'm not shabby either. I'm just out of practice. Yeah, I'll claim that. So we are jumping in, and I always show git log. The very last commit was the episode 39 commit. That's fine. Normally, I will then say git status and say, look, I haven't changed anything, but I have changed something. And what have I changed? Well, git diff. There. All that I've done is I've taken a few things out of the to-do list, the functions, and we had already done the ternary operator, so I removed that. And that's it. So I'm going to just say git commit -am update to-do list. You know, I'll say master to-do list. Sure, why not? Okay, now we've got a clean slate. And we want to have a continue operation. Now, of course, that means we're going to have an AST node representing the continue. And one for the break. And so we're just going to copy I really kind of want to just copy AST node, but I don't want to because that's there's a lot of stuff in there that we really don't need. So include AST node, which one? You know, I use integer a lot. I'll do that. So this is going to be include AST node break.hpp. We'll do the same thing, but with a continue.hpp, and now copy source AST node integer, and this will be source AST node break.cpp, and same thing with continue.cpp. Okay, and let's edit our make file because we know that these will both have to exist in some form later. But for right now, so edit the make file. So we need a break and continue. Assign. So we'll go after Boolean. Break, and then the continue, we'll go after the cast. Okay, so after, what did I say, Boolean? that, I need... Now we need a break. Oh, I still don't know how this works. 71, 72, substitute Boolean for break. There. And then after, what was the other one? Corey doesn't remember. Go back up to the top. After the cast is the continue. So there's the cast. And now 136, 137 substitute cast for continue. There we go. All right, so our makefile works, or we've updated it. And it's going to start complaining, but I'm going to go ahead and get the compilation working. So make test-watch. Yeah. We have to fix our thing. So what do we need to do? Let's star break and star continue. See if that, nope, it didn't work. I was thinking that the glob would work. Evidently, I'm just out of practice on how that works. There we go. Okay, so for this one, this is, we're in break, node break. Okay, so %s, and we need to replace integer with all caps break. And then do the same thing again, %s, the lowercase integer with lowercase, or title case, break. Okay. All right, that's just to get us through. This is, we're in the break.cpp, so we'll repeat the integer break. Okay. And now this one is the continue, so we will replace integer with continue. And we'll do the same thing with the title case, continue. And now the next one is just the title case one. There we go. All right, now let's go back and clean this up. So this will, an AST node that represents a break statement. Okay. Constructor, we don't need to know a number, we just need to know the location. Now you could have it so that you could say break 3 and it would break 3 levels out. That could be. I'm not going to do that. Just have a dump and override, and we don't need any of that. In fact, there. Simple enough. Let's go to the next one. This is the break class. So we don't need that. We don't need. There we go. Yes. All right, and now for the compile. We're going to have, this is going to be an opcode. So break will be a jump. Okay. But where to? Well, we don't know that yet. So we're going to put a 0 and do some other stuff. So this isn't working yet, but a break is essentially a jump. Yes. Okay. So let's go to the next one, and a continue that represents a continue statement. Don't need any of that. Same thing, we don't need to pass it anything, and we don't have anything to store. Okay, and then the last but not least, let's fix up the constructor. As you know, continue, we don't need this. Okay, and then this will be the same, a jump, bytecode 0, and we don't know where we're jumping to, but we're at least saying that much. Okay, we should have a clean compile at this point. All that we've done is we've set up a break and a continue. They're almost identical. The difference is where do they jump to? A break statement should exit the control structure that it's in. A continue statement should jump to the test. So for a while loop or a for loop, it should jump to whatever's supposed to happen afterwards. In the case of an if statement, it should jump to the increment line, and because it does the increment, then it does the test. And in the case of a while statement, it should just jump to the condition test. That's what a continue should do. Break should just exit it. All right. So everything's compiling. Let's. My caps lock was not on. Let's edit flex and bison. Why? Because we need to add some words. So I'm in bison right now. I like to do it in order. That way I'm thinking about it. And we've got these keywords. So we had print. Let's add break and continue. Simple enough. Now we know we're going to need to do a pound include for these. Do I care about alphabetical order here? I don't know. Break and continue. And of course, well, it's not going to do anything yet, but now we go to flex, and we need to tell it about these words break and continue. So we're going to, when it sees the keyword break, just say make break. And when it finds a continue, make continue. Simple enough. Everything should still compile. Flex isn't giving us any errors. And now we need to continue with the bison part. So what is that, you ask? Well, these need to be statements. They're closed statements, right? All of our standalone stuff is closed. So let's just add it right. Is this good? Sure. Let's see. There we go. But instead of return, it's going to be a break. And we just make shared AST node break. And all that we need to give it is a location. That's fine. And we can do the same thing with continue. Okay. Let's see. Bison did not no 17 shift reduce conflicts. Why? What did we do? Is it because let's see if we can figure this out really quick. It's probably something unrelated to this. So if I run it, it's going to tell me, as you see, 17. So if I say -w counter examples, what's the last thing that we did? I don't remember. Let's go to the first one. Oh, we added functions. And it doesn't know where to put a parenthesis. Okay. Because that is an operator. So just pulling up the order of operations. There we go. And just moving down to where we define the order of operations. Here we go. And where's the equal? Yep, so we're in reverse order. So the unary minus, or unary not the minus, or negative, I should say. Oh, unary plus and minus, yes, there. That's at this level, and so parenthesis is at a higher level. So, and it is left to right. So we just add left and that should fix our shift reduce conflict. I should have tested that. It's gone. All right. Continue with the build. So now what do we have? We've got we've told it how to recognize a break and a continue. And it just creates these AST nodes, break and continue. Now we need to decide how do we compile it. And this is where the work starts. Breaking and continue are going to be compiled similarly. I'm going to focus on one first. Which one do I want to do? Let's do the continue. For no reason other than I just arbitrarily chose. It starts with a C and my name starts with a C. So is that arbitrary enough for you? So we're going to edit our test document, add a test case, and let's just need to grab one here. You know, let's go up to the while. There we go. And this is going to be control flow, but it's not a while. It's actually a break. No, wait, I say continue. Continue. And let's see what this will look like. And I want to say, so we're going to do this as a raw string. There we go. We'll say a is equal to 1 while that don't want to lose all of that. Okay, so what are we going to say? We're going to say a is equal to a plus 1. We want that to happen. And that's always got to happen. But let's say if a is less than, or how about greater than 5. Continue. So it should jump up, and so we should only, oh wait, and then what was I going to do after that? Print A. All right. What would we expect the output of this to be? First of all, that's what we want, and we're checking the output, and we want it to be if it's greater than 5, it's just going to continue. But if it's less than, it's not. So it's going to start off with a 2. You know, we could make it change the a to equal 0 for the start. It's going to equal 1, 2, 3, 4. Evidently, I don't know how to do my closing quotes, and we'll make this to be a 0. Okay. Should not pass. Good. Because we haven't told it how to compile continue. So that's what we've got to do now. Now's the hard part. What is well, before we actually, I'm surprised it didn't give me a loop. An infinite loop, because I said just jump to 0. Is there no bytecode? Syntax error, unexpected closing quote. Where did I do that? Oh, it was indeed a syntax error. There should have been a semicolon there. Now it's going to give me I'm sure, a segmentation fault. Yep, it does. Why? Because I'm dereferencing something that doesn't exist. Okay. So what does this look like currently? We've got null val, that's our placeholder for A, and our string hi. We put in an integer 0, poke that into A, pop, that's fine. Load A, integer 10, compare less than, and if it is less than, jump to 42. But that would just load A, print it, and then that's in. But it's not. It's definitely less than, so it would go on. So it would load A, integer 1, add them together, poke that into A, pop it off, okay. Peak 0, that's load A, compare it to 5 if it's greater than. So it says jump if false. So if it's greater than, it's not greater than, so it's going to be false. So it's going to jump to 33, which is put a null value on, and then it gets popped off, okay. Now we peek A, print it, pop the result of the print, jump to 9, which is the where we load A again to do our A plus 1. Excuse me, where we do our test, our conditional test. However, if it's true, we jump to 0. A 0, no val. We push. It's like we start all over, and I don't know why it stopped. I don't know why why we didn't run out, because at that point it's like we're starting over. We've got an infinite loop. This is something we need to fix. So how can we do this? Well, this is going to be a combination of things. First of all, we have to have something that we can track in the program itself. So we're going to edit the source program yes, the include program.hpp, and we need, just like we've got set jump target, set function stack declaration, we need a and there's an add identifier. We need to have something that's like add break. Yes, that's what we need, actually. So we are going to, in the privates, we're going to have a this is going to be a collection of well, no, we could do both, but we'll do this. Continue statement locations. And this is going to be a standard. You know, let's just do a set of size t, because these are the bytecode offsets. And we will call this the continue locations. And we will add our setters and getters. So I need to say because I've got to go. I've got to pause. I'll be right back. All right, and I am back. Excuse me. So I know I just said add a setter and a getter. That is not quite what I meant. I mean, that was just something I could write down really quick while my phone was ringing so I could remember what I was doing. What we actually want to do is we want to have a function that, let's see, avoid and add continue. Yes. And what does that take? A size underscore t. And this will be the location. All right, and we're going to do another. I'll just go ahead and write them right now. Add break size underscore t location. And then we're also going to have a void set continues. How about set continue targets? And this takes in also a size t that will be a target. And we'll do the same thing with break. Set break targets. And we're going to need to add some code. So we'll say, what does add continue does? It will add the bytecode location of a continue opcode to be set when, not a continue opcode of a continue statement to be set when the final target is known at a later time. Sure. And at param we've got location, and it is the offset location of the continue bytecode. And it doesn't return anything. Okay. Of a break statement. Of the break bytecode. But it's really just a jump bytecode. That's fine. All right. Now, what is this set continue targets? It is going to for all continue bytecode locations collected by add continue, set the target PC to target. That's fine. At param target the target PC. PC, is that right? You say, Corey, that is bad grammar. I'll say, of course it is. I know that. Funny little thing about grammar. All the rules are made up. They're conventions. All right, so we've got continue locations, and let's do the same thing for the break locations. Okay, so we've got continue locations, break locations. For the sake of, I'm putting break before continue. Just for the sake of, what's the word I'm trying to say? I don't know, my brain stopped working. Alphabetical order. There we go. In fact, there we go. I'm just moving these around. Okay, so I've got add break targets, add continue, add break, set break targets, add continue, set continue targets. Simple enough. And we are in program.hpp, so we need to edit source program.cpp. There we go. And And what is add break going to do? If we look at the previous, what is that called? Break locations and continue locations, and it's set, and I never remember this. So C++ set. Is it append? Insert. Fine. So we'll say this break locations dot insert location. Add continue locations dot insert location. Simple enough. And so what are we going to do for the targets? All right, so we will say for auto, now these are just numbers, so I don't have to do the ampersand, but I in this arrow continue locations. What are we going to do? This arrow set, and I don't remember the name of this, so let's scroll up. Set jump target, opcode address, and then jump target. Okay. Jump target of I is target, and then this continue locations dot, and it should be clear. We can double check that just to make sure. Clear, yes. So what is this planning on doing? At some point, we're going to say add, I'm turning on the fan just to circulate some air. We're going to say add a continue, so insert that continue. But we don't know where yet. So we're just saying, hey, at some point there's going to be some continues that need to be populated. And then at another point, we're going to say, okay, all the continues that exist, set all their targets. And once I've done that, clear them out. Why? Because someone else somewhere else may need to add a place to it. So, all right. Is this sufficient? This is not enough. Why? Because it could be that we are inside of say a function or a while loop. We declare a function. I'm not saying this is a good idea, but I'm saying it's possible that there's a function declared and it has its own, or there's a break or something inside of it, and yeah. What am I saying? Here, I can write an example. Forget the whole function thing. If I were to say while, 1, doesn't matter. If, whatever, just inside of this while, wait. If a break, okay? And now while 2. And then inside of this, a break. Well, the way that this is written at the moment, it'll compile the first break and put it in the break locations. And then it'll get to the second break and put that in there. And then when we get to the end of the while, it'll say, hey, set all of the break targets. I know I'm working on location target. But it's the same thing right now, or the same concept. It would try to set both of these to whatever it should be for the while. So we need to increase the depth. So we need a vector of these, and we need to increase the depth and decrease them. So, okay, that's fine. We can do this. Whoops. So I'm going to go back, and we've got our set break locations, but this needs to be a vector of same way for the continue. Okay, so these are vectors. So we're going to say push break environment. And pop break environment. Now the question is would a break versus a continue have the same environment things? I mean, they maybe one day will add switches, in which case break would apply to a switch, a continue would not. So they do need to be separate. Okay, so let's okay. I know the way to handle this. What we're going to do is we're going to say push is going to increase the environment stack so that we can handle, what's a good way of putting this? What am I trying to say? So that we can handle nested breaking structures. Yeah, I think that's right. Nested breaking structures. Now, what about this pop? It doesn't exist. Why? Because when we set the break targets, we should pop. So let's add that. So we'll pop the, nope, in fact, forget that. Forget set break targets. We're going to say this is going to be our pop break environment. So we've got our push break environment, our pop break environment, and our add break. There. Push break environment, add break, pop break environment. I'm good with that. And we're going to do the same thing with this. We're going to have a push continue environment. Continue supporting, and I think I like that better. Okay. And then instead of set continue this is going to be pop continue environment. Okay. So now we've got 6 functions. And did I make both of these vectors? I did, break locations and continue locations. That's fine. Let's go back here. This is going to be, we've got to add break, and then now it's going to be pop break environment. Add continue. I haven't saved this, by the way. This isn't going to compile yet. Pop continue environment. Okay. Now, we need a push break environment. Doesn't take anything, and all that we're going to say is this break locations dot push back an empty one. Okay, that's fine. And we'll do the same thing here. Push continue environment. All right. And the last thing is, let's line that up. Equal is the shortcut for that. Okay, we're not done yet. So the push is going to just push one back. Okay, to add, we need to say dot back dot insert. Okay. To pop it, we will do this. We will, I'll come back to that. I'll do this. So push, that's correct. This needs to be dot back dot insert. There we go. So continue locations dot back. We just set all the jump targets, and then pop back. Yeah. This is no longer continue locations. This is break locations, and this is should be break locations. I think this should work. I'm saved it, so it's recompiling. Tell me if I've got any syntax errors. No syntax errors. Okay, but we haven't done anything with this. So in our program, when we add an identifier, no. When we pop an environment, no, push, where's when we push an environment, prepare the identifier stack, the string mapping, and now we need to say prepare the break locations stack. Probably should have called that break stack and continue stack. In fact, I'm going to do that. break stack. And so we're going to call it this arrow break stack dot push back. That should work. And then prepare the why did I say push back? No, it should be this arrow push break why am I fighting this mentally? Because we didn't need to have a helper function for these, but the way break and continue work, we will need one, so that's fine. I'm on line 53. What is this called? Push break environment, pop break environment. That's fine. Is that a good name? Maybe changing all the names, you never know. I think, okay, let's just call it push break stack. Prepare the continue stack. This push continue stack. Okay. Now, when we are popping it, we need to do the same thing. We need to say this pop break stack, and it needs to be this arrow what is it called? I don't remember. Bytecode. Dot size. Okay. And we're just saying if there's any break opcodes, then fill them in. If there's any that have fallen through the cracks. Same thing. Try to fill in continue opcodes. All right, now let's fix the name. So we're gonna go with break stack and continue stack. So Corey, you've changed this like 15 times. I know. Push break stack, and this is going to be called break stack stack, stack. I probably could have done this. You know what? We're gonna do it. %s ONTINUE ENVIRN, and that's going to be called ONTINU. Why am I doing that? Because sometimes the C is upper and sometimes it's lowercase. Continue stack. There. Okay, now I think we've got it all. Let's double check this. Push continue stack. Push back empty. Add a continue. We go to the back and just insert it. Here we go through it and then pop back. Okay, now let's this is break stack, and then this will be stack. And all right, see if it compiles at least. Hope so. It's still not fully working. We know that. We don't have a push break stack. So what is it? Oh, push break environment. Took all that time to get to that point. All right, so far. Now, let's have the magic happen. So we know that the problem is there should be a jump. Yeah, this one right here. Jump 0 should not be a 0. It should be something else. What? We don't know yet. So, and which one are we doing? We're doing the continue. So, okay. If I go to the ASC node continue, that's buffer 4. We've added the bytecode, and now we want to call program.add continue. And it's going to be program.get bytecode.size. Is that right? See if that compiles. Yes, it did. Okay, so we're going to say add the continue. No. Record the fact that there is a continue statement here. And then the continue statement is represented by a jump opcode. Okay, that's fine. That's just so that I know what's going on. I'll go ahead and save it. It's not going to change the way it's compiling. But now we need to say when we would want to do this, or when we would need this executed. Let's go with the while statement first. So in order to do that, we need to edit the source of the AST node while. And when we're compiling, the very first thing that we need to do is, well, okay, that's fine. But, oh wait, this one is going to be, we need a step before this now, and it's going to be either or break or continue. So no. So the goal here is that I've just started a while statement. So the first thing I do is to say, you know what, if there is a break or a continue during this, I want the break to be for my context here, the context of this while loop. So I'm pushing something onto the break stack, pushing something onto the continue stack. Yep. Now, a break or a continue is weird in that it doesn't push anything onto the stack. That's important to know because something should always be left on the stack. Right? Yes. So wherever these jump to, okay, so now we've got our condition start and the condition is false, blah blah blah, but let's do this. Jump back up to the condition. We know the code. when it's false, jump past the pop. Okay. Set we now know where a break statement should jump to. And where does it need to go to? Because we have to pass it, we have to set all the locations. So if you hit break on a while loop, it should go to the end and it's not pushing anything on. So it's almost as if you had just jumped to a false. Excuse me, the condition were false. So program get bytecode dot size plus 1. There we go. And now we now know where a continue statement should jump to. And where is that? So the continue should go to the condition. So where's the condition? Condition start. Let's see. Segmentation fault. That's always a good thing. Let's go to the test. I'm not even executing this. Where on earth am I getting a segmentation fault then? Well, let's examine this. This, by the way, strikes fear in my heart. Why? Because I don't know GDB that well. But we're just going to try it. Okay. I know a few commands and not many. R was run and BT is backtrace. So let's see. For that, it's buried. So it's that's standard library stuff. So the last thing, pop environment. CPP line 88. Okay, let's go there. We said pop break stack. So it tells me that break stack doesn't have anything in it. Did I forget? Now, by the way, you say, Court, why don't you just put a test on it? Make sure that there's something there before you pop it. No, 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 no. It should work. It should never get here without anything, there. So where did I get to this pop environment from? From the compile line 119, and that is pop environment. That's at the end of the compile. So I got to the end of the compile. When I do the push environment, I do push break stack, push continue stack. Okay. When I pop the environment, pop break stack, pop continue stack. Now the question is did I do a stupid copy paste error? So push break stack does a break stack, push, add break stack is break stack not back. Okay. Pop break stack is break stack pop back. Push continue stack is continue stack. Okay. I'm just making sure I didn't like do something wrong here. Add continue is on the continue stack. Pop continue stack is continue stack back, and continue stack pop back. Okay. And I would also check in the AST node while I push the break stack, push the continue stack, and then I pop the break stack, pop the continue stack. Sure. Okay. That makes sense. Let's recompile. Told you, copy paste error. Oh, and looky here. 31. I can already see there's a jump 9. And what is this? This is a continue, which means it should jump to the test, which is right here. Yes, because that is the start of, where is our test? 7. A is equal to 0, and that's going to be A is equal to 0, so we poke, integer 0, poke that into A, pop it, and then 9 is the start of the loop. And we set it. Yes. Okay. So now here's the question. Do we get 1, 2, 3, 4? We get, did that just run? And we get 1, 2, 3, 4, 5 high. Oh, of course, because it's only when it's greater than 5. So when it's 5, it's not going to continue. So it's going to get 5, and then it prints high at the very end. Yes. This is working. Yeah. Oh, and it finished. It passed everything. Okay. So the continue works. I want to try more than one continue. So what can we do? We can say while a is less than 10, if a is less than 3, continue. If a is greater than 7, continue. And it prints out 3, 4, 5, 6, 7 high. That is correct. Of course, I had to make my output match. 3, 4, 5, 6, 7 high. Yeah, so it matched multiple continues. Now, we need to do a for loop, but we haven't written the for loop yet. So, we need to write the for loop. Let me go ahead and there we go. Just get it all on screen here. This will be 3, 4, 3, 4, 4. A is equal to 0. A is less than 10. A is equal to A plus 1. We should get the same thing, but it's going to fail. I already know it's going to fail. Because we haven't done the continues yet. You say, Corey, why did we get anything? What, why did this do 1, 2, 3, 4, 5? Well, because I put it in a safeguard. That is, and I'm just going to show it to you, and I wrote it intentionally this way, but in our program.cpp, so, whoops. There we go. Okay, so in our program.cpp, where is that? In 9. When we pop, pop the environment, that's right here. When we pop the environment, I intentionally fill in any break opcodes that are missing and any continue opcodes, and they will jump to the end of the program. I did that intentionally so that we never have anything going back to 0. I did that, yes. So, and if you look, by the way, in the first one, it would, if I go back to, is it 4? No, it's not. 7. Here we go. In the first one, it will print out the 1, 2, 3, 4, 5, but then when it gets to the continue, because I haven't told the for statement how to handle a continue, it's going to jump to the exit. And that's why it never prints out the high. So that's why it printed out 1, 2, 3, 4, 5, not 1, 2, 3, 4, 5 high. Okay? And that's actually why I added the high at the end. I wanted to make sure that I was still executing stuff. I wasn't automatically exiting the program. The second one prints out nothing. Why? Because over here, come on, there we go. Over here, the very first thing, a is equal to 0. If a is less than 3, continue. But we haven't told the for how to handle a continue yet, so it jumps to the end. Yes. So oddly enough, this, well, we could write a little test of that as well, just to make, I mean, that tells me that it's working, but we can write a test as well that shows that it's working. And it doesn't error out. It's an important thing. Let's add it to the for statement, shall we? And so we've got our buffer 10 is our node while. Let's edit source AST node 4. All right, and our compile. And we're just going to yank that, paste it there. So we're pushing on the break and continue. And then we get to the end, and these aren't going to be exactly the same, but they might be pretty close. All right, so where does this need to go? When we get to a break, it needs to go to the end. That is exactly right. What about a continue? A continue should go to the, not the condition, the increment. And where is the increment? Do we compile the increment? We are not tracking its location. So we need to. Increment start is program.get bytecode.size. All right. Now, one other thing I'm going to do, since I'm here, I don't like these -1 expressions that I've been doing. So just cleaning them up as we get to them. But is that just going to work? I'm thinking it might. Watch me miss something obvious, but it failed. Oh! It worked. I just have the wrong answer in my test. Why? Because when I was doing the whiles, I started off at 0 and then I did a +1 immediately, and the for statements are just starting off at 1, and they should, 0, and it should start off at 1. So now this should be perfectly fine. Yep. All right. Now this one's going to be a very, very simple one. All that I'm going to do is I'm going to say continue and print high, and it should, well, there should only be one of them. In fact, I'll just do it so we can see that, yes, it does only print out 1. Yep. Whole point is that the continue jumps to the end. So that is our test to make sure that it doesn't just go up again to the 0. And The only reason I'm doing this is because I just love the fact, and it's a very small thing, but we've got our string high here, and it's only loaded once. And then we peek it for, and print pop jump to 13, which is the end, but there would be another. Oh. It tries to do a pop after that. Is that a problem? I don't think so, because it's an unconditional jump. Yeah, I think we're okay. For that matter, one of the optimizations that I have is removing anything that's immediately after an unconditional jump and until the next whatever something jumps to, because it's impossible for it to execute. So anyway, all right, get rid of that, and that is our breaks, our continues, and we really need to write some stuff for a break. So let's do that, shall we? There. I knew I had 2 lines there, and it was already driving me crazy. Well, I'll leave the continues here. I'll put the break up here. Okay, how do we want to change these? First of all, let's say if it is greater than 5, break. So all that we should get is the same, okay? Now this is harder to have 2 breaks. The only way we can do that is if we call the code twice. And you know what? We can. For b is equal to 0, b is less than 2, b is equal to b plus 1. And what am I doing with this? I'm glad you asked. I'm going to say if b mod 2 no, I'll just do it like this. If b is equal to 0, print 0, break. If b is equal to 1, oh, Corey, you can't write in your own language. I know, this is horrible. Print 1. Break. And part of the point of this is so that we never print out the A. So we've got a for and a while, and I kind of want to do this double layer thing. showing that the break works in 2 different locations and it's only 1 level. I know, you should unit test it, separate things, but, well, this is what I'm doing. You know what? I can say this. I can say if b mod 0, 0? No. 2 even odd. That should work. I don't even have to do it that way. I can just say else. And just to prove that print A is never reached. All right, so A is equal to 0. So that it gets reset. Just limit how many times it runs. This one should fail because I haven't even written what the test is supposed to do. Okay, it sounds like my computer is taking off, which means I have a an infinite loop. Okay, so it's either logic or we have a bug. B is equal to 0, B is less than 2, B is equal to B plus 1, that's fine. While A is less than 4, A is equal to A plus 1. If B mod 2, print even break, that should have exited the while loop. Else break. And all that it should print is even, then odd, and then that. So, oh wait, did I not? Well, no, I did. Let's do cout p2 dump bytecode. And we'll just keep it from going into the infinite loop, shall we? Wait, what? So we're not even executing. Well, crap. Because I don't have a good way of debugging this. The problem is right now we are in a loop in our compile statement. So it didn't happen until we started working with breaks. And this is the first instance of a nested one. So I've got a couple ideas. First of all, in the number 11, we popped break stack and popped continue stack. Okay. And in our continue, we do the same thing. Pop break, pop continue. That should work. But we can look just to make sure. We do that same thing, pop break, pop continue. So what does pop break and pop continue do? Go down, pop break, where are you? That seems right. It's gonna be in a recursive call. Come on, Corey, we should have been done with this by now. I know. Why am I doing this? Because control flow break. At the very bottom, when we're running the test, or we can say make test and it will just run, well, it'll run all three, but specifically it will only run one test here. Wait. Compiled, did it? And it passed. Oh. I don't think there's anything wrong. Well, there may have been, but yeah. I think I had highlighted something so it wasn't moving. That's the only thing I can think of. So now the question is, that's the infinite loop. Okay. I was like, why? What happened a moment ago is I ran this and I wasn't seeing all the output of it. And I was like, that means it's not even getting to the execute. Okay. And so it was a problem in the compilation. That's not the case. All right. So let's look at this. Null val, null val. That's going to be for the A and B. And then we've got an even, odd, and high. So that's 0, 1, 2, 3, and 4. Yeah. So integer 0, poke that into 0. Because that's B. Fine, pop. Peak 0, because now we've got to do the B is less than 2. Integer 2, less than, jump it false to 83. So 83 is going to be where we peak high, that's 4, print and exit. All right. Now, starting at 23, integer 0, poke 1, poke that into A, pop. So that's A is equal to 1. Now, we've got our peak 1. This is A, 4, less than, jump if false to 72. '72 is peak 0, integer, that's B, 1, add, poke it back into B, pop it, jump to 16. So, okay, that's the increment. Okay. So that was the jump if false to the increment. And that makes sense because if it's false, we go wherever, and that happens to be the increment statement. Good. All right, so now peak 1, that's A, integer 1, add them, and poke that back into 1, pop. Peak 0, which is B, integer 2, modulo, jump if false to 58. We're going to pretend that that's true. Peak 2, which is even, print it, pop, jump 0. That's our infinite loop. So what happened? When we exited while, we should have populated all of the whiles. And we did not. So this 54, and do we have another jump? 62 did not get populated. Okay. And where are those again? 54 and 62. Let's fix this. We can still see at least 62. All right, so we want to go into the while. So for this, we push the break stack and the continue stack. Then we popped the break stack and the continue stack. Do we do the same for the if? Or the for? Break stack continue, break and continue. And this is specifically the breaks. So when we pop break stack, I'm going to say cout setting break target at I. Should see those numbers. Specifically 62 and where was the other jump? 54 and 62. We're not seeing it. We probably will see it this time. Oh. There's a lot of breaks. But that's because it's always being called at the when we pop the scope. And so specifically it should be like these somewhere in this last one. The question is why is it not getting into break stack? Am I just missing something really, really obvious? I feel like I am. Target at I. I just want to see. It never goes into there, so how does it set the continue location? I really feel like I'm missing something painfully silly. And I doubt this will fix it, but Wait. Did I do something stupid? Is the question. Don't answer that. But seriously, why is the cout not running? I mean, usually it means I'm making a fundamental mistake in my thinking. Just like this should be setting break. And it never says setting break or setting continue. And yet we've got code where it's set. So we've got the control flow break. Control. Where's the continue? Oh. I commented it out. Remember I said? Fundamental mistake? Yeah. So we're setting continue. So I know that the continues are working. But the breaks are not. So I'm going to do cout Just want to know, does break depth ever get... It should be more than one. And on this one, a break depth of 3. Yeah. Why? Because it starts off... and... Why am I doing this? Just so you can see it. When you start off, it creates a break depth. You know, it creates the first level. And then we go into the for, and that creates a break depth. And then we go into the while, and that creates a break depth. So, here, yeah, 3. and then it gets called for 2, and then break depth of 1. Why does it not have anything there? Are breaks not getting added? Are breaks not getting added? Is that what I've done? Is that the stupid thing that I've missed? Breaks are not getting added. Oh, program add break. Sometimes. Look, it passes. Well, I haven't executed it, but this jump has a 64. Yeah. Sorry, it was the 54. Jump to 72. Let's see. And there's another one, 60. Yeah. That's it. Now, it's going to tell me it's failed. Oh, I need to get rid of the break dead. Let's see, where is that? That's going to be in program. But by the way, we'll see where it says setting break, blah, blah, blah. And did you notice it said what I said it would say? Was it odd then even or even then odd? And then high. Odd, even, high. That's what it was. Odd, even, high. Let's change those to capitals. Well, that was a massive red herring. But it works. Okay, so we've got a test where we're compiling we're breaking out of a while. We're breaking out of a while in 2 different places. Can we break out of a for? So it should give us 1, 2, 3, 4, 5 high. Okay. And then this would be more than 1 breaks, but we've already got that. And then just how about break? And we will call this 4 because it is number 4 now. Everything passes. We did it. Do we need to do anything else? It's like, I don't know, after that last bug where I just forgot to put in the code. I'm so mad about that. Control for flow break. We have breaks and continues. They work if you put them in a for. They work if you put them in a while, and they work if you don't put them anywhere that they should be. Let's see. What if you put them in a function? If you put it in a function, it should not exit, and I think this is going to show a problem. So let's do this. Let's function A print 1 break print 2 call A print 3. I would expect this to print out 1 then 3. Right? And I don't think it's going to. I think it's only going to print out a 1. Yep. Why? Because we don't tell function how to. That's easy to fix. So this is AST, no, source, AST node, function declaration. And in the compile, we've done all of this stuff. Okay, so the problem is this. Ensure that the function is cleaned up by calling return. Auto function return it's going to expect for there to be something on the stack. Okay, so the easiest thing to do is to write our little, write ourselves a note. To account for any stray, continue, or break statements. However, well, yeah, return expects there to be a value, a return value on the stack, something that continue and break do not provide. Therefore, we must provide a dummy value that will only be evaluated in the case that a stray continue or break is being evaluated. The simple solution is to, at this time, execution, jump over a command to add the dummy value but make the stray continue and break statements jump to the dummy value. Make sense? So here's what we're going to do. Program.add bytecode. Opcode jump. Program.add bytecode. Where are we jumping to? We'll come back to that in a moment. Program.add bytecode. Null val. And that's it. So, where's this going to jump to? Plus how many? Okay, so the size is going to be this current bytecode that's being added. So size is the current one. If I say +1, it will point to this. If I say +2, it will be the return. So the answer is +2. Now, of course, we have to write this, but... Or did I already write the test? Print 1. Oh, and now... I forgot the other side. Now, make all of the stray continue and break statements jump to the null val opcode, and that's going to be size -1. Program dot pop break stack Is that the right number? So, bytecode.size is 1 past null val. Size -1 is null val. That's right. One last problem. We just popped the break and continue stacks, but they will be popped again when the function is completed compiling. So push the stacks so that there will push the stacks so that the push pop symmetry is maintained. Program dot push break stack program dot push continue stack. I think that that should work. And it did. Look, the test worked. So we had to jump over this null val. We had to set all of the breaks and continues, but by doing that it popped something off that we didn't want popped yet, so we had to push something empty on, and then all is right with the world. So let's go back to our tests and Do the same thing with the continue. Well, the problem is it is now a 6. Continue, but it should also print out 13 because a continue in this case will have the same effect. And it does indeed. Okay, now we can say that we've got it. We've got breaks, continues. They work in the function scope. They work in their local scope of a while, their local scope of a for, and in the scope of the program as a whole. And it wasn't that hard. I was sidetracked for a few minutes because I forgot to finish writing the code for the break. But aside from that, we're done. So let's do this. Let's get status, get diff, see what all did we do? Of course, yes, Bison and Flex. We've got our variables properly documented. That is it. Uh, 298 lines added. Well, yeah. Oh, I don't remember how to amend a commit and push it. I know that says you shouldn't force, but I may do it just because no one's there yet. And I'm doing it on video. Okay. Oh, it opened in Nano. Why? Add break and continue statements. But that's okay. I made my students learn Nano as their first command line editor. Why? Because I told them it's always going to be there. And you need to know that at the bottom, Control O is for write out. And in this case, exit. So Control X. And it's not going to like it. Oops. Yeah. I'm sorry, people. It was ugly, but I did it. And now if we say, not GitLab, GitHub. Where's Tang? There we go. And our history. Yeah. Had break and continue statements. It's there. It's not pretty, but it's there. All right. So last few things. rm-rf docs and make our docs PDF. Let that run for a second. We've got a couple new files in there. There, we'll let that WSL view. Where is this? Docs, not LaTeX. HTML index. There we go. We've got our new files that are like the continue. Yeah, it's there. Okay. Our commits good. Our compile worked. Passed all of our tests. Oh, those are the untracked. These are the tracked. Forget all those. I forgot to add the break and continue files. Sure. Now git add docs, git commit -m updating docs for episode. What episode are we on? I don't know. I paused it and ate lunch or supper. Episode 40. For episode 40. There we go. And usually make clock. Oh, we're so close. Almost 5,000 lines. What are we going to be doing next? I have no idea. I'll look at my to-do list. I could have removed something from the to-do list. But what do we care about at the moment? We have break and continue statements. Wasn't too taxing on the brain. Still can't believe that one bug is just finish writing the code, Corey, and it'll go away. All right. Well, if you made it this far, congratulations. But yeah, we got it, and our language is growing in what it can do, how we can express information. Maybe we want to look at arrays, potentially, or do we want to tackle some of the Unicode stuff? Don't know. Unicode's got to come at some point. It's a beast to get going. But I think I kind of want to... maybe I'm leaning towards the arrays, just because they're so helpful. If we can get arrays and then the ranged for, that'll be pretty nice. So, having said that, again, thank you for joining. And as always, hey, I'm hoping this is beneficial in some way. Episode 40, it's done, and 41's next. So, thank you. Have a great day. Bye.